is Lesson 5. Lesson 5 consists of two parts. Part 1 is kinetic and potential energy. Part 2 is law of conservation of energy and energy transformations. Let's start out with our guided question. This is now page 16 in your interactive notebook. And our guided question for this is, what are kinetic and potential energy? Kinetic energy is the energy of motion. For example, the action of hitting a baseball with a baseball bat is obviously energy of motion. The person is transferring the energy through the bat into the ball, and then the ball has kinetic motion also as it moves through the air. Potential energy is what we call stored energy. Okay? This large 55-gallon drum, or however big it is, holds like petroleum or oil, which is a fossil fuel, which we would consider as stored energy. It has potential to become kinetic energy, but it's stored at this point. All energy forms exist as potential energy or kinetic energy or a combination of both. We can look at it in this way, kind of like a graphic organizer of what our energy sources that we know so far and where they fall in a diagram when we separate them out to be potential or kinetic. Potential energy forms are things such as chemical energy, fossil fuels and biomass, nuclear energy, which is the energy stored in atoms, stored mechanical energy, like a stretched rubber band has some stored mechanical energy, and gravitational energy, which is hydropower. Water falls over a waterfall due to gravity, so it's gravitational energy. Kinetic energy, on the other hand, we have electromagnetic energy, which of course is light energy. We know those move in waves, transverse waves. So transverse waves are of course moving energy, which is kinetic. Thermal energy is heat energy. Heat energy is the movement of molecules in something, which generates the heat energy. Motion energy, for example, wind, the windmills that we get energy for. Sound energy, we learn that sound moves in longitudinal waves. So you know that moving things, again, making the connection to kinetic if it's moving. And electrical energy. We touched on that when we talked about the electrons moving through cords is what electricity is electrical energy, is the movement of the electrons. That wraps up part 1 of these 2 notes. So now we can move on to page 18. The topic here is the law of conservation of energy and energy transformations. We have 2 guiding questions for this page of notes. Number 1, what is the law of conservation of energy? And number 2, how is energy transformed? And why are energy transformations important? First of all, here's the law of conservation of energy. Energy cannot be created or destroyed. But energy does change form. And when it changes form, we refer to this as an energy transformation. Energy can transform in order for us to use it. So we have all these wonderful sources of energy that we learned about. We learned about solar power and wind and geothermal and biomass and all the fossil fuels. Okay? They exist, but in order for us to use them, we must change that into another form that's usable. Right? And they refer to electricity as a secondary source of energy because we use all those sources that we learned about and we put in our energy book in order to get electricity from those. And that puts it in a usable form for us. For example, you have a lamp. And that lamp is run on electricity. And the lamp gives off, of course, light. And remember, lamps also give off heat. So in this example, energy is being transformed from the electricity into thermal or heat energy and light energy. In class, we're going to do a worksheet that has a lot of different examples of energy transformations. So when you come back to class, we'll have that to work on. Okay, here is an example of the law of conservation of energy, and an example of potential and kinetic energy and how they can exist, and how something exists as either potential or kinetic or a combination of both. You don't have a place in your notes to put this down. This is just something that I put together as a visual for you. You may see something like this again in class. I have a similar worksheet like this that you may see. So you don't need to record anything in your notes. Okay, just watch and see if you can connect why this shows the law of conservation of energy. Remember, that is that energy cannot be created or destroyed, and that energy is just transformed. So here we have a burning building, and Mrs. Felter's artwork is not, the best. But we have a person who's on top of the building, and these are my flames coming out of the building, and you see smoke up there. Okay? And that little person is standing at the top. When that person is up there at the top, that person would have potential energy. Okay? And just for example's sake, let's say that person has 10,000 joules. J stands for joules, which is a measurement of energy. Or a unit, I should say. Remember, no naked numbers, so we always have to have something dressing up our numbers so we know what that number means. And at this point, she or he, this little person, has 10,000 joules of potential energy. And just standing there, they're not moving. So if something is not moving, it can't possibly have any kinetic energy. So it has 0 joules of kinetic energy. Okay? Now, I'm going to fast forward through a few frames of this and watch as the little figure falls, and then we'll go back and we'll look at the different energy values. So I want you to think about what's happening to her potential energy and her kinetic energy as she falls down to the ground. Okay, let's watch her again. One more time. Let's watch her go down. Okay. Let's get her where she's at the second step. Okay. Now she's starting to fall, and she's losing some of her potential energy because it is now being transformed into energy of motion or kinetic energy. Now, as she begins to fall, we get to this point. Now, like I said, she's losing some of her potential energy because now it's being converted into kinetic energy. She's starting to move as she jumps off the burning building. So at this point, she has a potential energy of about 9,000 joules. And remember, she started out with a total of 10,000 joules of energy. So energy can't be created or destroyed. So she, at any point in her fall from this building, she will always have a total of 10,000 joules of energy in some form or another. So that leaves us with 1,000 joules of kinetic energy. As she goes farther, her potential now is decreasing. We're down to about 7,500 joules of potential and 2,500 of kinetic. I'm going to just fill some of these in, and then we'll look at them all together. She's gone down a little farther as her potential continues to decrease. Her kinetic continues to increase. Nearing the bottom, so now she's past the point where her potential energy is greater than her kinetic energy. Now she has picked up more and more speed, so her energy of motion is much greater than her stored energy. And as she hits the bottom, at the point of impact, her potential energy is now 0, and her kinetic energy has been totally transformed from potential to kinetic, and she has a total of 10,000 joules of kinetic. So let's go back and take a look at this all together and review how energy is not created or destroyed, but just transformed. So here you can see the total amount of energy is 10,000 joules. And at any point, as she falls down to the ground, okay, each point adds up. So the total energy, amount of energy, the total amount of energy remains constant. In this case, 10,000 joules. That concludes our lesson on kinetic energy, potential energy, the law of conservation of energy, and energy transformations. We have lots more to do with this in class, so we'll see you there.